In this lecture, we are going to discuss previous EAMCET solutions. Topic is redox reactions and 2021 questions. Okay. So first one, which of the following is not a disproportionation reaction? What is a disproportionation reaction? The reaction in which same element undergoes both oxidation and reduction. Okay. Same element undergoes both oxidation and reduction. Okay, see here, let us assign the oxidation state for each and every element involved. See here, in the elemental state, oxidation state is 0. So oxygen here -2, oxidation state, hydrogen is +1. Okay, see here, chlorine is in +1 oxidation state, oxygen is in -2 oxidation state. See here, chlorine -1, here hydrogen +1, oxygen -2. Okay, see here what is happening. Chlorine here from 0 to +1 means it is undergoing oxidation. At the same time, another chlorine from 0 to, see here, what is this, -1. Okay, so one is going oxidation, another one is going reduction. So that's why it is a disproportionation reaction. And next, see here, fluorine 0. Okay, see here, oxygen -2, hydrogen +1. And here oxygen is in +2 oxidation state, fluorine is -1. See here, fluorine -1, +1, -2. See here, oxygen oxidation state here -2 to +2, and here same, means only it is undergoing, one oxygen is undergoing oxidation only, no reduction. And look at this, fluorine 0 to -1, 0 to -1 means only it is undergoing reduction. So that's why it is not a disproportionation reaction. And the next one, see here, chlorine is in +5 oxidation state, oxygen -2. See here, chlorine is in -1, and here chlorine is +7 oxidation state. So +5 to -1 reduction, +5 to +7 oxidation. So chlorine is undergoing both oxidation and reduction, so it is a disproportionation reaction. And here chlorine is in +1 oxidation state, oxygen -2, here chlorine -1, and here chlorine +5. Okay, so +1 to -1, +1 to -1 reduction, +1 to +5 oxidation. So A, C, D. In all these all are disproportionation reactions. So this is not a disproportionation reaction. So the correct option is B. Okay, like this, just assign the oxidation states and easily we can identify which is a disproportionation reaction. Okay, clear? Next, from the given reactions, identify the disproportionation reaction. So this is very, very important. So many times questions are asked. Same thing here also. 0, here potassium +1, iodine is in -1 oxidation state. See here, +1, -1, this 0. Okay, so here chlorine, only it is undergoing reduction, and potassium oxidation state is same, iodine -1 to 0 means only undergoing oxidation. So this is not a disproportionation reaction. Next here, chlorine is in 0 oxidation state, -2 for hydrogen +1, and here chlorine +1, oxygen is -2, chlorine is in -1, hydrogen +1, oxygen -2. Okay, so next, see here, from chlorine 0 to +1 oxidation, 0 to -1 reduction. So this is a disproportionation reaction. And these are also you can check. Suppose here magnesium is in 0 elemental state, oxidation state is 0. Okay, I have already explained in one video how to identify the oxidation states and rules to assign the oxidation states. I will give the link in the description. If anybody don't know how to assign the oxidation states, you can watch that video. Okay, and here hydrogen +1, chlorine -1, and here magnesium is in +2 oxidation state, chlorine -1, hydrogen 0. Okay, so here none of the element is undergoing both oxidation and reduction, so that's why it is not a disproportionation reaction. Okay, and see here, this hydrogen +1, oxygen is in -1. See, this is hydrogen peroxide, very, very important. Oxygen is in the -1 oxidation state, and here hydrogen is +1 only, oxygen is -2, and here in the elemental state, oxidation state is 0. See, oxygen -1 to -2 reduction, -1 to 0 oxidation. So that's why this one, see here, this is under a disproportionation reaction and this is also a disproportionation reaction. So 2 and 4, option B is correct. 2 and 4, option B is correct. Okay. KMnO4 oxidizes oxalic acid in acidic medium. The number of moles of CO2 produced per mole of KMnO4 is. So first let us write the reaction, this one. Okay, so here KMnO4 plus oxalic acid H2C2O4 in acidic medium, let us take H2SO4. Okay, so KMnO4 H2C2O4, I will balance later. And here the products are MnSO4, manganese sulfate is formed, plus carbon dioxide is formed, plus potassium sulfate K2SO4 is formed, and also water is produced. Okay, so if we balance this, here 2 moles of KMnO4, 5 moles of oxalic acid and 3 moles of H2SO4. So here we get MnSO4 and 10 moles of CO2 and 8 moles of water and 2 moles of MnSO4 are produced. So here what is the question here? They ask you to find how many moles of CO2 is produced per mole of KMnO4. See, from this reaction, 2 moles of KMnO4 is producing how many moles of carbon dioxide? 10 moles of carbon dioxide. Okay, so 1 mole will produce how many moles of CO2? 10 by 2. That is equal to 5 moles of CO2 is produced. Okay, so option A is correct. Which among the following species act as a self-indicator? Okay, so here our answer is permanganate, okay, or potassium permanganate. So here KMnO4, what is this? Potassium permanganate. So if you take MnO4 minus, that is permanganate ion. Okay, so it acts as a self-indicator because originally it is in purple color. Okay, KMnO4 is in purple color. What is the role of indicator? It used to detect the end point by changing its colors. Okay, so here actually when it is titrated against a reducing agent, KMnO4 is a oxidizing agent. When it is titrated against any reducing agent, like suppose oxalic acid, just now we discussed the reaction also. Okay, in this case what happens? Its color changes to pink, or after if you shake this it becomes colorless also. Okay, and again what happens after this total reducing agent is consumed, again the solution becomes purple. Okay, so means like this, see here it is color showing the change in color. So this is how we can end what when it will change after end point. Okay, so like this it is acting. We are not using any other indicators like phenolphthalein or methyl orange. Itself it is a indicator. Okay. Next, which among the following species does not show disproportionation reaction? See how many times questions are asked related to disproportionation concept. Very, very important. Okay, see here, first let us see the oxidation states of these elements which are participating in the reaction. So here chlorine is in +1 oxidation state, oxygen -2. Here chlorine is in +3 oxidation state, here +5, here +7. Okay, so our answer is option D, because see here chlorine is in the highest possible oxidation state. What is this? Here chlorine is in the highest possible or maximum oxidation state. Okay, so more than this it is impossible because already all the 7 valence electrons were removed. Okay, means the only choice for this one is it can undergo reduction, but it cannot undergo further oxidation. Means It cannot undergo a disproportionation reaction. Yes or no? If anything is undergoing disproportionation, just now we discussed, the element must undergo both oxidation and reduction, but here it can undergo reduction only. So that's why it does not show disproportionation reaction. Okay. Thank you for watching. In the next lecture, we will discuss 2022 questions from this redox reactions concept. Thank you.